I'm going to talk about the trigonometric double angle identities. I'll assume that you're familiar with the trigonometric sum and difference identities. If not, I would invite you to watch my video on those identities. So let me first list the trigonometric double angle identities. Then I will show you how to derive them, and then I'll do some examples. So here they are. The sine of 2 alpha is equal to 2 times the sine of alpha times the cosine of alpha. The cosine of 2 alpha is equal to the cosine squared of alpha minus the sine squared of alpha. And then finally, the tangent of 2 alpha is equal to 2 times the tangent of alpha all over the difference 1 minus the tangent squared of alpha. So to derive the trigonometric double angle identities, we will use the trigonometric sum identities. So using the sum identity with respect to sine, what would happen if we used alpha plus alpha? That would give sine alpha times the cosine of alpha plus the cosine of alpha times the sine of alpha. That's equal to 2 times the sine of alpha times the cosine of alpha. All right, so far so good. Now let's try the sum identity with respect to cosine and alpha plus alpha. So that would give the cosine of alpha times the cosine of alpha minus the sine of alpha times the sine of alpha. That simplifies to cosine squared alpha minus sine squared alpha. And then we'll do likewise for the tangent function, the tangent of alpha plus alpha, using the sum identity with respect to the tangent function. I get the tangent of alpha plus the tangent of alpha over 1 minus the tangent of alpha times the tangent of alpha. That simplifies to 2 times the tangent of alpha all over 1 minus tangent squared of alpha. Suppose you were in the middle of a long calculation and you ended up with 2 trigonometric expressions that you suspected were equivalent. All right? Can we use the given identities to prove that they are equivalent? So specifically, can we do the following? Prove the sine of t minus the cosine of t all squared is equal to 1 minus the sine of 2t. So you can modify the left side, you could modify the right side, you could modify both sides, as long as you get to something where it's obvious that this is true. So let me do this. Let me expand the left side. So I'm going to go ahead and do what's called FOIL. Some people call it FOIL to expand it. And so I get the sine squared of t minus 2 times the sine of t cosine of t plus the cosine squared of t. And we know from the Pythagorean identity that the first and last terms add up to 1. So I get 1 minus 2 times sine of t cosine of t. But we also know from the double angle identity with respect to sine that that second term is the sine of 2t. So 1 minus the sine of 2t, which is exactly what we had originally on the right side. So we've just proven that indeed that identity is true. Okay? Now let me invite you to do one. So can you do this? Prove that the cotangent of x minus the tangent of x is equal to 2 times the cotangent of 2x. So pause the video and try that if you like. Alright, so I'll go ahead and work it out as well. This time I'm going to play with the right side. So 2 times the cotangent of 2x, that's equivalent to 2 divided by the tangent of 2x. And the tangent of 2x, I can use the double angle identity to replace that with 2 times the tangent of x over 1 minus tangent squared of x. And let's see, so now the 2's cancel, and let me move the 1 minus tangent squared of x to the numerator. Okay, now let me split it into 2 fractions. 1 over the tangent of x minus, and then the tangent squared of x over the tangent of x, I can simplify that to just the tangent of x. The first term, the reciprocal of the tangent of x, that's the cotangent of x minus the tangent of x. And look what I've just done. I've just shown that the right side of the original identity, suspected identity, is equivalent to the left side. So indeed the identity has been proven to be true. Okay? Now try one more. Can you prove that 1 minus the tangent squared of alpha over 1 plus the tangent squared of alpha is equal to the cosine of 2 alpha? Pause the video if you like and try to work that out. Okay, so I will go ahead and work it out now as well. So what I'm going to do is play with the right side. I'm going to use the double angle identity with respect to cosine to express the right side as the cosine squared of alpha minus the sine squared of alpha. But now I'm going to do one more thing. I can divide that, what I just wrote, I can divide that by 1, right? That's allowed. But I'm going to divide it by 1 expressed the following way. As the cosine squared of alpha plus the sine squared of alpha. And so the reason that I'm doing that is because now I can divide everything by the cosine of alpha, everything on the top and bottom. So let me make it clear what I'm suggesting. Divide everything at the top by cosine squared of alpha, and divide everything on the bottom by cosine squared of alpha. Okay, so the first term in the numerator becomes a 1. The second term becomes sine squared over cosine squared, but that's equal to the tangent squared of alpha. On the bottom, I have a 1 for the first term, and then the second term is, again, the tangent squared of alpha. So I've converted the right side of the original suspected identity to the left side, so indeed the identity has been proven to be true.